February 15th, 2013. At latitude 55.150 degrees north and longitude 61.410 degrees east, 61.410 degrees east, on the morning of February 15th, 2013, at 3:20 UTC, a super bolide 20 meters in diameter, weighing between 12 and 13,000 metric tons, crossed Earth's atmosphere at around 20 kilometers per second and exploded in an airburst at around 30 kilometers altitude, releasing around 500 kilotons of explosive energy, 20 to 30 times that of the A-bomb dropped on Hiroshima. Although occurring on the same day as the highly publicized expected near-miss flyby of the massive asteroid 2012 DA-14, the initial reaction to the Chelyabinsk event from an expert publicly online, Phil Plait at Bad Astronomer, described their difference as being a solid 12 plus hours between the event and the expected closest proximity of asteroid DA-14 to Earth, which occurred around 16 hours later. Although initial official reports to Reuters Newswire described the event by saying only that an object exploded at about 32,000 feet above the Earth, this initial misidentification led another government expert who spoke to Moscow FM radio station to say he believed it may have been a bolide, a type of meteor that explodes in the Earth's atmosphere because of its composition or angle of entry, according to a report the following day in the New York Times. According to Wikipedia, the International Astronomical Union defines a bolide fireball as a meteor brighter than any of the planets, magnitude -4 or greater. It was later confirmed to have been brighter than sunlight as well, and based on video of the event analyzed initially by Phil Plait, there was a shock wave about 20 seconds in from the meteoroid hitting Earth's atmosphere, measuring a 2.7 seismic wave, which would have seemed to confirm this. However, again, according to the New York Times article the following day, the governor of the Chelyabinsk region reported that a search team had found an impact crater on the outskirts of a city about 50 miles west of Chelyabinsk, which would indicate the meteor did not explode in the atmosphere, thus proving all prior initial official reports wrong and reclassifying the event as a meteorite impact. By November 14th, later the same year as the event, a full analysis of the event was published in the scientific journal Nature. According to this report, there is a strong likelihood that the Chelyabinsk meteor had, previously to its impact, been an Apollo asteroid in a close orbit to unusually large, estimated 2.22 kilometers in diameter, near-Earth asteroid 86039, formerly 1999 NC-43, for at least the last 1,000 years. However, the report goes on to clarify earlier rumors that the impact could not have been predicted due to the trajectory of the asteroid's radiant being inbound to Earth from the same direction as the Sun. More recent articles, collected on open-source online encyclopedia website Wikipedia, indicate additional traits of the event such as that the hypocenter of the first of 3 blasts, each with different amounts of kinetic energy released a flash of light brighter than the sun, enough to leave some residents sunburned for weeks afterwards, followed around 2.5 minutes later by an infrasound shock wave, which was responsible for about 1,500 medical injuries due to glass windows of around 7,200 buildings across 6 cities in the southern Ural region, all being blown out at once. The reason the bright flash, which itself lasted about 5 seconds, preceded the sound by such a long duration was that, as the meteorite entered the atmosphere, it was traveling almost 60 times the local atmospheric sound barrier. The first flash emitted 90 kilotons of energy as photons alone and caused the meteor to break in 2 pieces, one falling apart after 18.5 kilometers and the other remaining luminous down to 13.6 kilometers, the largest portion, around 60 centimeters and weighing 654 kilograms, appearing to have held together enough kinetic energy, still traveling at 64% the speed of sound, to puncture the frozen surface of Lake Cherbarkul. Segment 7. The Yamal Craters, July 15th, 2014. The first reported occurrence of this, yet somewhat mysterious phenomenon, was based on aerial video footage shot by engineer Konstantin Nikolaev from Yugra and published as an anonymously authored article in the Siberian Times on July 15th, 2014. This report contains the first mention of the explanation, initially posited, according to the article, by Anna Kurchatova of the Subarctic Scientific Research Center, that Arctic methane release from permafrost, exacerbated due to global warming effects, caused the 60-meter wide crater around 70 meters deep, which was explored, as reported on in the Siberian Times on July 17, 2014, by senior researcher from the Scientific Research Center of the Arctic, Andrei Plenkayanov, and a team of other scientists who confirmed the base of the crater contained unusually high concentrations of methane. Since then, the mainstream scientific explanation for this event has been geothermal heat flux, causing methane hydrate eruptions, similar to those occurring along the Kara Sea, between Yamal Peninsula and Novaya Zemlya, where gas flares have been reported of up to 25 meters in height, as the Siberian tundra's permafrost layer begins to melt due to regional climate heating. The second occurrence of this phenomenon to have been discovered was found several thousand kilometers away from the first, still in the Siberian peninsular province called Yamal, which, in the language of the indigenous inhabitants, the Nenets, means end of the land, or world's end. However, this one was reported by locals to have formed in a bright flash on September 27, 2013, in the Taz district near the village of Antepeyota, and has a smaller diameter than the first occurrence, of some 15 meters, compared to the 60-meter diameter estimated for the first discovery site. The same July 28, 2014 article from the Siberian Times, reporting on the discovery of the Taz district crater, also reported a third occurrence, discovered along a reindeer herder route by residents of Nosok village in the Taimyr Peninsula, to the east of Yamal, in the Kransoyark region. Initial estimates of this hole placed its depth at between 60 and 100 meters and its diameter at more than 4 meters. Subsequent exploration of the second Yamal crater by the Russian Center of Arctic Exploration, reported on by Anna Lisowska in the Siberian Times on November 12, 2014, discovered a 10.5 meter deep frozen surface lake at the basin of the additionally 16.5 meter deep funnel or pit of the crater. In an article dated February 23, 2015, Anna Lisowska again reported in the Siberian Times on additional findings by Deputy Director of Moscow's Oil and Gas Research Institute, part of the Russian Academy of Sciences, Vasily Bogoyavlensky. Based on analysis of satellite photos of the region both before and after the formation of the craters, and revealed the existence of another crater, even closer to the first occurrence, that has become a lake. This crater, designated as B2, is located only 10 kilometers from the Bovanenkova supergiant natural gas field, developed by Gazprom following its discovery in 1972, until 2012, when it went into operation as an extraction plant fully 20 kilometers closer than the first discovered crater, some 30 kilometers to the south of the gas field. The B2 crater that has filled in with degassing water to form a large round lake is surrounded by around 20 smaller craters, also filled into lakes by degassing water, some of which are very small, no more than 2 meters in diameter, according to Bogoyavlensky. Analysis of satellite imagery of the area appears to show a pingo, or small, non-glacially formed permafrost hill, in the area prior to the formation of the crater or funnel phenomenon, and this, as well as the video and photographic evidence taken by the Russian Center for Arctic Exploration in the funnel, later designated B3, that indicate a large underground pocket or void forming below the surface prior to the event, half submerged in the frozen lake formed at its basin, both indicate the premise of this phenomenon being caused by methane hydrate eruptions as being a plausible scenario, as methane displaced in subpermafrost aquifers away from the Bovanenkova gas fields by their recent initiation of natural gas extraction operations there, could be boiling up in nearby regions, resulting in the explosive formation of funnels comparable to the cones of volcanoes. However, this also implies that the entire Yamal or Kurug could become an active caldera due to the accidental conflagration of humanity's methane harvesting there. As Professor Bogoyavlensky points out ominously, a concentration of 5 to 16% methane is explosive. The most explosive concentration is 9.5%. For now, at least, the Yamal craters at the end of the world remain a great modern mystery.